All right, what you're going to do now is you're going to determine which of these lines that I've given you here, which of these have the exact same steepness. Again, our starting point hasn't been specified, so we can't say that they would be the exact same lines, but I'm looking for you to find lines that have the exact same steepness, which is just another way of saying they're parallel. If you have your notes in front of you, what you can do is you can just try and pick any starting point and then start moving according to what you're reading here, and see if you can find two lines that were parallel. Another thing you can look at is you can decide the correlation. So if you go right 3 and down, I know the correlation would be here would be negative. If I move left 4 and down 1, left 4 and down 1, I'm going to get something that looks like that. That would be positive correlation. So what you can do is you can determine first off what the correlations would be, and then when you try and match for the same steepness, of course they would also have to have the same correlation. So I think this is another time to ponder pause to give you a chance to match these up. All right, resuming to just have a quick discussion on these. Again, initially I had suggested, we had just started by listing the correlation, and I had suggested you match together the ones that have the same correlation. So left and down would have positive correlation, right and up is positive correlation, up and right is positive correlation, up and left would be negative correlation, up and left would be negative correlation, and down and right would be negative correlation. And these two that I've got highlighted in blue would match, and how they would match is if I would take this move and I imagine multiplying by -1. So positive 5 there would become -5, so that's how we go from right to left 5. This is really a -3. If you multiply it by -1, instead of going down, you will now be going up 3. These two in orange belong together, and again that's another multiply by -1. So if you're going left 10, that would be -10, times -1 would be +10, and that will become your right. And down 6, which is -6, times -1 becomes +6, and that becomes our up. Let's take a look at the green moves on the bottom. I've got down 1, right 4. If I multiply by -3, what will happen is 1 times, this is -1 because it's down 1, times -3 will give me +3. That becomes up 3. Right 3 is +4 times -3 becomes -12, and that becomes left 12. So those match up with the same steepness. And the last one to do, I guess, to look at is the purple one. So I'm starting with up 2 and right 8. Both of those would be positive numbers. If I multiply 2 by -1/2, I'll get -1. So the up 2 has become down 1. And if I do +8 times -1/2, I'll get -4. The right 8 has become left 4. So you can see there's many different ways of describing a line based on a slope, because all of those numbers that we had written earlier over here as fractions, they're all reducing to the same thing. So I'm going to give you a formal definition right now. What is the formal definition of slope? So slope is defined as the ratio of the rise, which is your up-down change, over the run, which is your left-right change. It is a vector quantity, as opposed to a scalar, which is just the magnitude. It has a magnitude and a sign, and the sign will tell you the correlation. If slope is positive, the line is moving up to the right. That's a positive slope. If the slope is negative, the line is moving down to the right. So to the right and down. And this would be to the right and up. So that's what we mean by saying it's a vector quantity. The direction is going to tell you the correlation. The magnitude would be the actual numbers when you divide them, so that's going to tell you how steep they are. So it's possible for two lines to have the exact same steepness. So you can imagine a ladder, and then if I were to try to reflect this, let's see if it will allow me to reflect that. I'm going to copy it. Whoops. Bring that down here. Try and line it up with that. And then I'm going to flip that left-right. Slide it over. All right, so if those were ladders, they would now be equally steep. But one has positive correlation and one has negative correlation. So slope is going to tell you two things. It's going to give you a measure of steepness, and it's also going to tell you something about the correlation. All right, what I would like you to do next now is we're going to go back to the grids again. This time, would be this one down here. I had to change it a little bit because the previous one I was using is a Flash product and it wouldn't work, so I redid these in Geometry Sketchfile. So here you are here. Now I would like you to look at how the grid, this is where we were. We had radio buttons for up, down, and left, right. This is where we are now. So now how are you going to address the left, right issue now when you don't have the radio buttons? So that's the first thing I want you to think about on this particular, get the car back home to the driveway. Input a slope that will do that. Try several different examples. Again, it still works the same way. If you want a new example, you click like that. When you're ready to go, you start the car. If you want to reset the car, you can. You can erase the traces at any point in time by clicking Erase Traces, and then see if you can figure out how to address these slope calculations or the slope of the line that would sort of connect the car to the home. Again, I think this is a time to ponder, pause, and as I said, I would like you to work through at least 4 to 6 examples to prove to yourself that you've mastered the concept.